Hi, this is Dr. David G. Stork, adjunct professor at Stanford University and author of the forthcoming Pixels and Paintings, Foundations of Computer-Assisted Connoisseurship. I'm on The Edge of AI, the podcast curated especially for the connoisseurs of the finest AI knowledge. Stay tuned.
Hello, AI podcast passengers. Jump on in. Here's what's to come on today's journey. Find out what AI can do to help us better appreciate and understand art. How today's guest is optimistic about the future based on evidence from his own experience. And finally, when and when not to use computers to learn stuff. All this and more on today's episode.
Welcome aboard the Edge of AI podcast. Snap into your safety belt and prepare to explore the depths of the rapidly expanding AI universe. Each episode is a dispatch featuring hyper-relevant reports from the pilots, pioneers, and passengers aboard the AI rocket ship. We explore the latest use cases and developments in AI, hear from experts building tech, and learn how this disruptive force is transforming industries and society.
You are about to embark on another stellar podcast journey brought to you by The Edge of Company, empowering pioneers of Web3 tech and culture responsible for other groundbreaking endeavors like the Outer Edge LA Innovation Festival and the Edge of NFT podcast. Find out more at edgeof.xyz, edgeofnft.com, and outeredgela.live. Ahoy there, AI travelers. It's going to be quite a voyage today at the Edge of AI, led by yours truly. I'm your captain, Eathan Janney. I'm driving this ship with my unique perspective as a polymath. I've ventured into the realms of music, art, science, and business, and I go deep. That means I'm a neuroscience PhD, but I'm also a registered piano technician. I'm also a co-founder at Edge of Company. We empower tech and cultural pioneers through top-notch endeavors like this very AI podcast, Spaceship. And today's guest will help me guide you through uncharted territories where we'll unravel the mysteries of AI and push the boundaries of its impact. Are you ready to chart a course for innovation? Anchors away, my friends. Today's guest is David G. Stork, distinguished scientist, author, and innovator with significant contributions to various fields, among them machine learning, pattern recognition, computer vision, and artificial intelligence. Dr. Stork holds a BS in physics from the MIT with a thesis under Edwin Land, then president and CEO of the Polaroid Corporation, and his MS and PhD in physics from the University of Maryland. Dr. Stork's pioneering work spans across academia, industry, and entrepreneurship. He has held faculty positions at Wellesley and Swarthmore Colleges, as well as Clark Boston and Stanford Universities, teaching in disciplines ranging from physics to computer science. And his expertise extends to diverse domains, including electrical engineering, statistics, neuroscience, psychology, and art, as well as art history. A prolific author and researcher, David has 220 plus peer-reviewed scholarly works and 8 books to his name covering a diversity of topics, including computational optics and image analysis of fine art. Additionally, Dr. Stork holds 64 U.S. patents. He is a fellow of many respected organizations, such as the Institute for Electrical and Electronics Engineers and other organizations in the fields of optics and imaging. At the time of this interview, David and I are both fellows at the 2023 Leonardo at Jurassic residency in Woodside, California. It's 5 weeks of precious time and space to develop our work at the intersection of arts and sciences. While here, David is putting the final touches on his upcoming book titled Pixels and Paintings, Foundations of Computer-Assisted Connoisseurship. David, welcome to the Edge of AI.
Thank you very much. It's a great pleasure to be here in such a gorgeous environment.
Yes, and we were talking about this since day one of the residency, right? Sitting outside in the beautiful mountain countryside and thinking, wow, we could probably film this out there. And it turns out the lighting is not so consistent. So we get to look at a beautiful view of mountains, which is behind the camera, and we're kind of sitting in the library of the sort of artist residence area. But we're still having a lot of fun, and it's a beautiful setting. Maybe you'll be able to, if you're watching on YouTube, like check out some of the interesting titles in the background. So yeah, I think one of the reasons I thought, what a great opportunity to have you on the podcast as one of our foundational episodes as well, is because you've been viewing this whole thing from the, not the very beginning, but kind of things
not that old.
along the way. You've probably seen this thing from places where they might not have even called it AI, right? Because the predecessor to AI. So I'd love to kind of get a little bit of an insight into where your exposure to what you see, the foundations of what we're now calling AI. Where did that start?
Well, I won't go to the history before I participated, but I mean, personally, I worked at the Center for Adaptive Systems at Boston University. I was a professor there for 2 years, which was one of the leading centers for neural-inspired computation and biologically relevant neural networks. And I was working on things like computer models for lip reading, putting together the sound and the sight for speech recognition. And then when I came out to Stanford, I worked in the lab of David Rummelhart, who's most famous for developing the backpropagation learning algorithm for 3-layer neural networks. And at that time, we knew some of the limitations and so forth, and we all envisioned and imagined a day where we would get what are now called deep networks, and here we are. So it's been a long, slow road of increasing theoretical understanding of neural systems, most importantly, getting massive data sets, as I'm sure your audience knows, and you, and the compute power in order to lead to systems like ChatGPT, which is the presenting case now, but DALL-E and many other, deep neural network systems.
Yeah, appreciate that. And, I think the listenership that we're aiming for here is going to be an interesting diversity, right? We're going to have probably some folks that are actually building some of the tech in the background, like we're talking about, some of them that are using the tech maybe for entrepreneurial or purposes of an organization or a movement of some sorts. And also, we'd love to give insights to kind of just the average person who's intellectually curious about what's going on here, and get the context here. So like that history piece is really useful. And just for a little bit of vocab, maybe one of our first kind of vocab words here on the program, deep network, right?
Deep neural networks, deep learning, sure.
What makes it deep, and why was that not a capacity, at the time you were working on the lip reading, for example?
Sure. Well, to step back one step further, there was sort of an intellectual competition between two general approaches towards AI. One was expert systems, where you would write down lots of rules, for instance, in linguistic rules, and the other was basically machine learning or statistical learning and statistical pattern recognition, where instead of trying to put down rules, you gave lots of examples and let the system learn the statistical relationships between them. And if you had to give a prize for who wins, it's definitely the statistics ones. Those are have proven far more accurate, reliable, extendable, and so forth. And that's what deep neural networks comes from. The basic idea is that you would have layers of very simple processors, call them neurons, call them nodes, where you would put input, be it an image, be it sound, and so forth, and you take weighted sums of the values of these inputs to get small groupings of these, and then you get more and more layers and more and more layers, and at the end you'll get an output, maybe like 2 neurons. One says a cat is visible or a cat is not visible. And the real question was, how do you train the weights, train the connections between them? And my host colleague, David Rummelhart and McClellan, came up with the backpropagation learning algorithm, which says it's basically just calculus, but how do you take an error at the output and change the weights so that the next time that same input is put in, you're going to more likely get the correct answer. And the one of the problems was you wanted to have many, many layers so that you could do things like translation invariance in image analysis. If I have a cat here, I might be able to recognize it. But then what if the cat's over here? Well, you need it's simplest to do this by having many, many layers. And the backpropagation algorithm extended to these many, many layers made it seem it was rather difficult. And I won't talk about the real mathematics behind it, but given enough patterns, examples of cats in different positions, or the imposition, the scientist knows that we want translation invariance. So put in the architecture itself that notion of if you can recognize something here, you should be able to recognize it here. You can put that in constraints. That plus now the access to literally billions of pictures of, rooms and people and horses and cats and so forth. We can train these networks to be highly accurate, and they're now rivaling and in some cases surpassing human performance on very difficult pattern recognition problems.
Right. And I think I can break it down in probably an oversimplified version, but tell me if this sounds about right. Let's imagine I have a piece of graph paper, and I've colored in the pixels of the graph paper, put it that way, the cells, to look like a cat to me, right? And you're saying that basically I have a translation of whatever that image is into another image on another piece of graph paper, into another image on another piece of graph paper, to the point where at the end, if it's all black, it's a cat, and if it's all white, it's not a cat. Kind of like...
It's sort of like that. You don't need to have a whole large number of output neurons if your goal is just a cat or not cat. It's just either one neuron or two neurons.
Right. Maybe it narrows it down to a smaller frame every time, and it's either a black pixel or a white pixel.
And the key thing to modify in that excellent, accurate description is that at each layer, one of those cells on your graph paper, as you call it, doesn't necessarily represent a point in the field of view, but a particular feature, like a vertical line in a place, or a horizontal line, or as they get more and more higher in the network, curves or groupings and more abstract and harder to interpret features and groupings of features. So that's it in a nutshell.
In a nutshell. And I think that what's useful for again, the listener who's trying to figure out what are they doing behind the scenes? Have they somehow built like an actual brain, for a robot? I think the technology you're describing, even though we kind of described it for an image of a cat, you can use a similar technology to underlie something like ChatGPT, which is a text-based type of thing.
Yeah. There, you put in text as the input, and the desired output is the next word, sometimes groups of words, but just for simplicity, the next word in a sentence. So you give it a part of a sentence, and the output is, tell me what, of all the possible words that could go next, which is most likely to come.
Right.
And so ChatGPT puts together groupings of words and phrases and statistical correlations between words, and then does an accurate job of producing what the next word would be in sense. Then you can do it again and again and generate, whole paragraphs.
Yes, and this reminds me of I forget the scientist's name, unfortunately. Maybe you'll know, maybe what. But there was a TED Talk of a scientist. This is probably a good 10 years ago, and he set up his whole house full of cameras as his little baby was learning to talk, cameras and audio, and captured all the development of like wa, to wa wa, to wata, to water, right? Like all of that. And then also showed that there was a statistical connection between where the child was when it was using and learning these specific words. So for example, it learned how to say water in the kitchen, right? Because there was a proximity to like the actual water, and there's a statistical probability, right? That in the kitchen, I'm going to say water. And so every time you return, you say it more. And so I guess the interesting thing about that is the ChatGPT is learning to talk, it kind of seems like we do, even though, yeah.
Well, there's
on a much faster scale.
Well, yes, but there's a longer debate between cognitive neuroscientists and linguists, like Noam Chomsky and Steve Pinker are the strong proponents that there's innate structures ahead of time, that we've evolved to have certain structures, and that this pure statistical will not explain certain types of errors and learning, the rate of learning that humans do when they're learning language. The real question for your audience is, does it matter? Suppose we had that structure, we knew what that was, well, then we could train these things faster. However, if you just care about having a ChatGPT or other text generation system, another approach would be just flush the system with billions of examples, and it will abstract out and learn most of these kinds of regularities that we almost surely come innate with us.
Mm-hmm. Yeah. I saw a recent interview with Noam Chomsky, and he was very dismissive of ChatGPT in a way. You know, it's just like
statistics.
It's just statistics. Yeah. But it's pretty impressive.
I think it's impressive. Definitely, no question.
You made it sound quite unimpressive. But yeah, so I mean, we talked a little bit about it. We referred to it, but you worked several years for a camera company.
Ricoh. Mm-hmm. Yeah,
Ricoh,
chief scientist.
And so maybe you could tell us, you mentioned sort of the lip reading system. How did that compare, I guess? We alluded to it, but how does that compare with what we're doing today and what you were doing back then?
Oh, well, we were doing a number of projects. One was the infinite memory multifunction machine. If you think of copiers and faxes, wouldn't it be nice to store everything that ever came through your office, everything that then the question is, how do you find it? How do you search it? How do you organize it, and so forth? So there's sort of AI associated with that. I started a group there on computational sensing and imaging. I later took that those ideas to Rambus Corporation, where I was a Rambus fellow. And that's the idea that you can design, typically, for many, many years, people designed optical systems in order to get the highest quality optical image. And there'd still be some problems with it, but then you could fix those with some image processing. And then maybe if your goal was to recognize a face, you would do computer vision on the end. Mm-hmm. The computational imaging revolution or approach is saying, well, maybe we don't need to get a high quality traditional optical image. If we get the information that's useful for the task at hand, looking for the color of skin, for instance, that's going to be really helpful in finding faces.
So that's how they do it.
Well, yeah, sort of. Well, there's skin and features and so forth. And so I worked for many years on simplifying the optics in very special ways so that the optical image that gets captured contains the information that's relevant for the task at hand, like recognizing a face. Mm-hmm. Or imagine you're reading vertical barcodes. You don't really care to get the image sharp up and down. You just need it sharp left to right. So you would design different optical systems. And so we designed a very small camera that didn't even use lenses. It used, it's called a diffraction grating, basically a structured piece of metal where the light would come through and diffract in very special ways that had mathematical properties that we could undo in the processing. So yeah,
So one feature, I guess, of what you were doing, if we go back to what folks are doing today, is clearly it's more complicated but there's a basic principle that gets to be applied over and over and over again on many, many layers today with the AI that people are using for these deep systems versus some of the things that you were setting up, and people still have to set up things like this today, where you kind of had to meticulously go through and think, how would I read lips? There's an image component, there's an auditory component and you said you were talking about this previously outside of the interview, that you were in some ways either not using the auditory component or considering it separately to do the lip reading, right?
Well, yeah. I mean, you have the auditory processing, taking the sound that you hear from the speaker, as well as the video. And the question is, how do you put those together? So the simplest way is to get the acoustic signal and make a classification. Let's say we're just dealing with recognizing numbers. Did he say 5 or 6 or 7? And then you can get the one from the vision and watch his lips when he says, and get an estimate there and just put them together and say, given those two, what's the most likely? Or you could try to get the feature. So those are separate audio and separate video, and that does not take advantage of the fact that when you're doing certain lip motions, you're going to get certain sounds, and learning those earlier, that they're features that are audio visual. So instead of having a separate audio and a separate video, you make a hybrid system where the features themselves have some audio aspects and video aspects, and then do that. And that turns out to be a little more accurate. And I could talk for lip reading for a long time, but there's some very cool aspects to it. One is that the utterances that are difficult to distinguish by ear are easiest by eye, and vice versa. So for instance, ba and pa are visually indistinguishable. If I just do, you can't tell. And
for the listener, he's just mouthing if you were to say ba or pa. You could look in the mirror and see what that looks like.
Exactly. Ma and pa or ba. They're called visemes, like phonemes, but visemes. But they are very easy to distinguish acoustically. There's something called VOT, the voice onset time, the delay between the burst sound and the vocal folds going. So ba, they're together, and ah, there's a delay. So it's very easy. So, and there are examples vice versa. And they're really interesting acoustic, visual acoustic phenomena like the McGurk effect, where you take a video of someone saying ma, but the sound that is spliced with it is the sound of someone saying ga, a so-called back consonant. And the brain, if you're watching it, you hear da, you hear it mixing in between.
Oh, wow.
Yeah, it averages the back and the front, it's a middle. And it's really cool. You can have this thing going again, you hear it saying da, 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 and then you close your eyes so you don't get the visual, and you hear it say ga, 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 da, da, just by opening and closing your eyes.
Close your eyes and hear something different.
And our computer system had this same phenomena, had that same perception.
Right. And it's, so, so for the listener, you could look up the McGurk effect. I forget exactly how you spelled it. MC.
Capital M, small c, capital G-U-R-K.
G-U-R-K, yeah. It is fascinating. It's one of those things you look at it and you're like, what is going on here? It's a mind, plays with your mind. But I think what's interesting about the way that you were analyzing things is, you learn how complicated the human perception system is. You learn that it's like, oh wow, you don't realize it, but you're integrating auditory and visual, and you're even processing some other levels of things, other contexts. Yeah.
And that really hits you in speech. There's something called the Van Santen effect, where the context, it's best to explain by an experiment. If I have the utterance, like wheel on the axle, okay, but imagine I put in noise at the beginning, so it's wheel on the axle. You will hear the W. It's not, what could go there? I think it, no, it sounds like a W, even though the prime, as we say, is much later. But if I say heel on the shoe, you say, oh, I heard an H, heel on the shoe.
Right.
So there's context and knowledge at many, many layers. It's very, very fascinating kinds of
and then again, to demonstrate to folks maybe where things are different in sort of some of the models that are being used today, there's a possibility, we kind of imagined you could train like a speech recognition system using just this kind of multi-layer deep network system, and nobody would have to think through those details necessarily.
Exactly. Yeah, it's I've forgotten which speech recognition, computer speech recognition researcher said it, but I think it was at Johns Hopkins. He said, every time I fire a linguist and hire a statistician, my accuracy goes up. So in the era when large data sets are available, it actually doesn't matter that much which algorithm you use. It's who has the most data wins, so to speak.
Right. All right. Here's a question that's probably asked all too much, and you may or may not have an opinion on. But and we didn't talk about this previously, so you could wave it off. But any thoughts about what consciousness is, and how AI has access to it?
This is the hard problem. I mean, what people really are interested in is the hard problem. How do the intangible, subjective qualia of the read of that book arise from material processing of brains or computational systems? I don't have an answer to that. The best philosophers don't. And I'm hard-pressed to imagine even a candidate answer. Imagine I could tell you everything about their brain. We finally get to if you have these neurons firing at this rate and these neurons firing and this fire, and we can do that. And yes, when you did this, you say, yeah, I see red, or this is qualia. And when it does, imagine we do that. Decades of research and we get that. Does that answer it? I don't think so. You know, it's still another qualitatively different thing from the processing itself. And personally, I mean, I urge people to work on it. I don't see how they're going to ever solve it. I will read every paper that comes out that solves it. But I also don't think it matters that much because it's the processing, it's the actions, it's that people are going to be using, whether or not it's conscious or not. I don't know. I don't spend much time on that.
Don't worry about it. Yeah,
Sorry.
Other things to focus on.
And be leery of people who think they have an answer to it. Oh yeah. Anyway,
I figured it out.
Yes.
In your experience, what has been the most significant development in AI, particularly in the areas of machine learning, pattern recognition?
I think Jan LeCun's, my friend Jan LeCun's, and Jeff Hinton's, and the other pioneers in deep learning, that has really revolutionized AI and machine learning, that we could deal with data sets that involve a billion images of faces, for instance. Just the whole scale expanding beyond anything we dealt with when I started out in 3-layered neural networks back with David Rumelhart. So that, I would say, is definitely the most important.
And again, these systems have more layers, put it that way, than 3.
Many dozens, sometimes over 100.
Yeah. Just to give a context, it's not necessarily a billion layers.
Oh, no. But I mean, I think ChatGPT has something like 1.7 billion free parameters. Think of them as the connection weights. So it's a very large network. And this is too technical, but from a traditional statistician's viewpoint, when you have degrees of freedom, you traditionally need a certain number of training patterns per degree of freedom. Somehow that doesn't seem to be the case with these large networks, that there's redundancy and there are sort of biases built into these networks. That means that for as large as the network, large of the training sets we have, it really isn't many patterns per weight, that there are constraints that, and this is not fully understood how these systems work.
So it's just kind of like you're trying the system, it works, but I don't exactly know why or how.
Yes, people often worry about, can we get this AI to explain, to interpretable AI? I personally am not that interested in it because, frankly, humans aren't very good at explaining. When I teach my class at Stanford on pattern recognition, I start with the case of recognizing a chair. Oh, what is a chair? And someone will say, oh, it has 4 legs and a back and stuff like this. And I have a wonderful Taschen book called 1,000 Chairs. And I just flip and I open to, I don't even have to look. I just open, it says, I'll bet that doesn't conform to your definition. Oh, it only has a single post, or it's hanging from above. And the question is, you can recognize it's a chair, but how do you do it? And the whole point is, people, if I asked you, really pushed you against the wall, explain what a chair is, that would apply to every chair that everyone
else says
would
that's a
agree
chair.
it is a chair. You can't do it.
It's quite complicated.
It's quite, and then you get to really vague. It's called functionalism. You say, well, a chair is something that supports sitting. Well, yes. How? How can I tell whether something supports sitting? I mean, it's really very. So I'm not so. I understand for legal reasons, it's helpful to know whether when a machine makes a mistake, how you can debug it and so forth. Right. But from the scientific viewpoint, and it has interesting scientific sort of aspects to it, but it's not a problem I'm going to work on. When I build my systems, I don't worry. Will it be able to explain why it can recognize this painter versus that painter? Not really.
Right. Yeah. And in the essence, in the end, it can be, AI seems like it'd be better than us in terms of speed, especially and scope. And at the same time, it's the limitations of doing what we can do, our own limitations, right? We can only define chairs in the way that we can.
But we can give billions of examples of chairs. Mm-hmm. And even though we can't explain what it is about that image that makes me understand that it's a chair, the computer, properly trained with enough data, can. And again, I'm not so worried that it won't be able to say, oh yes, it's because the conjunction of this curve with that color, with this material that I'll leave that to someone else.
Exactly. All right, so we haven't really talked about this yet, which I think there are things that scare people about AI, and you could think about this in a scary way, or maybe in a good way. What do you think about AI replacing jobs? Like, how much are we going to see that?
I think you should really talk to an expert on that rather than me. I do think that there are going to be many repetitive tasks that get more and more replaced by AI. And the real question, and I'm not the expert, is, well, will that free people to be much more productive using these tools, or will it put them out of work? And I don't feel comfortable. I'm not expert enough in that realm to inform your readers and listeners.
Only time will tell.
Yeah. I want to talk about art.
Yes. Yeah. And actually, that leads me to my next question. So, I would love to talk about your book. It feels, as I've talked to you about over the past couple of weeks, something you're very passionate about. I mean, you've written textbooks, and not that you're not passionate about those subjects as well, but this feels kind of like a personally rewarding project. So maybe you could walk me through it. It's like a 10-chapter book, and
Sure. Well, the overarching sort of mission and vision is to use computation, computer vision, machine learning, AI, as a tool to help art scholars understand and interpret fine art paintings and drawings. So whenever I talk to art scholars, they get very defensive very quickly, and I allay their concerns by saying, no, this is a tool for you. You will still make the decision. This is a tool to help you, just the way as a microscope is a tool for a biologist and a telescope is a tool for an astronomer. These computational tools will be able to help you address problems you've done before, and actually perceive more accurately than even the best human connoisseurs or scholars or person off the street. For instance, lighting analysis. I'm going to be talking about lighting analysis in our open house here at Jurassic. My work on Vermeer. it turns out humans are not very good at looking at an image and saying where the light is coming from. And that's why so many so-called tampered photographs and fake photographs get by us. Someone will take a picture of Angelina and Brad, separate pictures, segment Brad out and paste it in with Angelina, and it will look perfectly good to most people. But there's no guarantee that the lighting directions on them in the individual photos
Really
are the same.
impossible, yeah.
Hani Farid and others have developed techniques called the occluding contour algorithm that are far more accurate than any human at being able to distinguish these and find those. And so I and my colleagues were the first to ever apply these to paintings to look at, for instance, the accuracy in the works of Vermeer, like Gerbil the Pearl Earring. And for the art scholars, I have to, no one's saying an artwork is better if the lighting is consistent. There are plenty of this, we're understanding the artwork as it is, that many artworks have very inconsistent lighting, like the Surrealists, Rene Magritte, for instance, we've worked on, and you say, oh, this cast shadow is here, this cast shadow, it's not making normative judgments, it's not a bad painting because of that, but these computer techniques can show it in ways that just looking, even a good connoisseur can't by eye. And so that's just one of the many examples of the kinds of tools we're developing to help art scholars analyze paintings. And I'm working on this today, actually, on one of our papers. One of my students, Jean-Paik Chow, worked on estimating the pose in portraits. So you have
the angle of the
head. Angles of the head, the roll, the tilt, and the yaw. And art scholars are interested in this because it is part of the aesthetic import of a painting. Is the person looking straight at you? Is it a profile view like this, and so forth? And they've been doing it rather informally. Oh, it looks like a 3/4 view and stuff like this. Well, not only can our system estimate all three angles very accurately, but it can do it on thousands of paintings in a few minutes. So if you're interested in how portrait pose has changed over the last 500 years, you could either take a few years and have a grad student go down one by, or you could use our software and get these plots very quickly. You can see how it changes in Rembrandt's time over his life. You can even tell whether an artist was right-handed or left-handed, because if I'm a portrait painter and I'm doing a self-portrait and have my mirror, if I'm right-handed, I'm going to put my canvas over here and something like this. If I'm left-handed, like this. And so there's going to be
a bias of your head.
A bias, exactly right. And out of 11,000, we can find which artists are right-handed, left-handed. Now, that's not earth-shattering art history.
I know you at home were wondering.
Yes, exactly. Everybody wonders, who is this artist left-handed? Like Leonardo was left-handed. But now we're working on adding gender identification. So are the portrait poses of women different from men over time? Have they, all those kinds of questions. So again, it's the tool. The art scholar says, oh, I'm interested in this. And here we have a tool that says, now you can do it on 11,000 paintings in 5 minutes. Get used to it. And there are yet others.
Yeah, fascinating. Any other particular like chapters or topics or things that you're interested in calling out? Or
Yeah. I mean, my deepest interest in AI and art centers over semantics. Now, there's a branch of, I'll call it traditional AI, called semantic image analysis, where you take a photograph and the AI will produce a caption. There's a man on a bicycle and he's pushing his daughter and there's a mountain in the background. And that's great. It's really quite remarkable that you can train a system to do this. But that's just describing, I'll say, the surface level, what is depicted. It's not addressing the problem of why the artist made it or the message or the meaning in the painting. And that's where art is so much richer than we'll call them natural photographs, your cell phone photographs. And so our first work was on Dutch vanitas paintings. In the Dutch Golden Age, 1650 to 1700 roughly, there were many still lifes that would have a skull and a candle with a flame out, and so you could just see the smoke, and a book and a musical instrument and so forth. And traditional AI, and I've run these systems on it, will be able to say, there's a skull there, but it misses why the artist made this, and which was to impart the lesson of vanitas, that don't concern yourselves with the pleasures of this life. Be prepared, live a humble, sober life so that you would have eternal salvation in heaven afterwards.
Right.
These were called painted sermons. Everyone understood them, everyone educated in what's now the Netherlands. And AI can't solve those, or we're now just getting AI to figure this out. So it's very simple, it's very restricted class. We're not near, for decades, being able to take a painting, get a scan of it, and have a 2-paragraph.
Right. What does it mean?
Yeah, exactly. Yeah. What does this Picasso mean? What does this Pollock mean? No.
Right. Or what could it mean? Of course, people look at paintings and say that
exactly. There are many. Exactly. It's culturally dependent, and there are multiple meanings, but some are more reasonable than others.
Yes.
And some go to what the artist explicitly intended. And those are the kinds of things we're after.
Yeah. Yeah, it would also be interesting if you could get it one day, I'm sure. Maybe we'll get there. We'll see how far. Where you could say, here's Eathan, here's his background, here's what he thinks about, here's his likes and what does this mean to him?
Yeah. Well,
what does this mean to David?
Well, there has been some, it's in my book, work on, they call it emotion, but is this painting upsetting? Does it involve, does it make you interested, and so forth? And you can learn, the AI can learn from a training set. In other words, if you see lots of paintings with bright colors and things, you'll think energy and so forth, and an AI can learn that reasonably well. But that's just categorization. Oh, this is, a painting that involves fear or something like that. I'm much more interested in, a deeper meaning rather than just the classification. Yeah. Because, that's what art is, why art is so much more interesting to me than photographs. Yes, there are some art photographs in which that comes to the fore, but the billions of photos on the internet and that I've been taking with my cell phone and so forth don't address that level of depth that the art, that, the greatest artworks must, like Las Meninas and things like this.
Mm-hmm. All right, I want to go on to our next segment, AI Wants to Know, in a moment, but I thought I'd share with you, because we had sort of like a pre-interview conversation and we discussed this. I was curious if ChatGPT could have any insight into one of your paintings, just from its understanding of the context, right? Yes. And so I said, I fed it, and you gave me, this is all I put. I actually intentionally kind of I was like, I don't know how to spell this, I'll just write it out, whatever. I put Herman van
Steenwijk.
Right? I probably spelled it wrong. Vanities of Human Life Allegory Painting.
Yes.
That's what I put.
And okay. ChatGPT
Here's
said?
What ChatGPT said. I'm sorry, but I couldn't find any specific information about a painting titled Herman van Steenwijk, Vanities of Human Life Allegory. It's possible that you may have misspelled the artist's names, da-da-da-da-da. But listen to what it said. Without more specific details, it can't provide a detailed analysis. However, I can give you a general understanding of allegorical paintings, and the concept of vanitas is often associated with symbolic representations, and the transience of life and futility of earthly pursuits. Allegory paintings are a work of art that use symbolic imagery. So very interestingly, just with a very vague input.
If you had spelled his name correctly on the painting, maybe we'd have more. No, that's exactly the kinds of things we did. We when we developed our AI system, we trained it on the texts that were specifically addressing these paintings. So we had them translated from Old Dutch and then modern ones in English, where it would find, oh yeah, skull, the word skull and mortality were often in the same sentence. So we trained what's called a knowledge network that between certain objects and certain concepts. But ChatGPT may have that. And tonight I'm going to put it in accurately and see how far it goes. And it's a good start. And yeah, I mean, it's kind of a foundation. And now we want to train it with more art knowledge and context and things like this. We're moving.
Fascinating stuff. Well, it'll be a very interesting book. And I guess, I don't know this last main question. I guess I'll ask it really quickly. Any final advice for a common person how to best embrace this coming AI wave?
Oh gosh.
He's a scholar. He's not a life coach.
Not a life coach.
But
gosh.
What comes to mind?
Be fascinated by it. I do think there are other people who are better placed to talk about the dangers of these, and I think there are real dangers associated with this, unintended consequences, that ways things can go wrong, and I do look forward to Chuck Schumer's legal approaches towards regulating and so forth. The bigger danger is bad actors. Even if we are completely responsible in the academy and AI corporations and so forth, there are bad actors out there, and we need to use AI. The only way I see to fight deepfakes and disinformation and so forth is with better. It's an arms race,
right? And
so we should have the best scholars working on how to root out, how to detect, how to root out the kinds of things that we know are going to be coming.
Yes.
I mean, you probably saw the deepfake Zelensky videos where he says, "Oh, fellow Ukrainians, put down your arms. We're done."
Oh, right.
When
I
that
didn't
starts,
see that.
yeah, when that starts getting out, there are real dangers. But again, there are much more versed scholars in that realm than me.
All right, we don't expect you to do everything. All right, next segment, it's going to be a little bit fun here. It's called AI Wants to Know, and also some of our fellow residents here help me tweak the questions here, so it's extra fun. AI is curious, and so are we. 10 quick questions designed to uncover the intriguing mysteries that AI longs to comprehend but can't quite grasp. It's a snack break in our journey, so keep the answers quick, but the safety belt sign is also off. So let's explore more of who you are and what makes you tick. Are you ready?
Let her rip.
All right. Number one, what's the first thing you ever remember being proud of?
Oh my God. You mean as a young child?
Sure. Or is when you can remember?
Oh, gee. I played music as a child, and there were a few times when I was proud at being able to complete a very simple Bach piece as a kid. On the piano.
For the listeners.
Yes, I wiggled my fingertips.
Yeah, and we didn't get to cover that much at all, but you're a percussionist
yes.
who played at the orchestral level.
Yeah.
All right, question number 2. What do you need help with that you wish you didn't?
Oh my goodness. I love to write. I find it immensely fulfilling, but it takes so much longer. I mean, I edit. It's basically edit. Every sentence in my 781-page book has been edited at least 10 times. And if I could speed that up, I would love to have that.
All right. Well, ChatGPT may be able to help.
Yeah.
All right. Question number 3. What do others often look to you for help with?
Oh gosh. Well, I mean, I teach at Stanford, so there, everyone in my class says,
how do I get an A?
Well, or I'm teaching Fourier transforms. They're going to say they want to learn from me on this kinds of stuff, or computational symbolic mathematics. I teach a course on basically using Mathematica to solve equations. So, I mean, as a teacher, I could go on for a long time, all the courses I've ever taught. I think what I can provide to a small group of people is how to integrate science and technology, or science and the arts. How, because I've been working on this for decades, and it's not obvious how, when it's appropriate, how you talk the different languages, how you answer questions that care to the artists or art scholars in ways that maybe the computer scientists can't. Things like that.
Yeah.
Sorry, that's kind of a little bit
that's a great
vague.
one. That's kind of why we're here, right?
Yeah, that's why we're here.
Stuff.
That's how I got in here.
All right. Question number 4. What do you treasure most about your human abilities?
The ability to look at a painting for sometimes hours and see more, understand more, be fulfilled more, be enriched more, be challenged more. Basically, it all has to do something with doing with my eyes, eyes and vision and seeing.
Beautiful. Question number 5, and yeah, we're in a larger room here where there's a little bit of cleaning going on, but the audio is pretty good. I'm testing it right now. So, but for the listener, there is somebody vacuuming. All right, question number 5. Throughout your whole life, what is the most consistent thing about you?
Fascination with the problem of seeing, recognition, pattern recognition, the mystery of how we do this. I mean, many people have had this little epiphany at age 7 or whatever. How do I recognize that's a car? Well, there's an image of a car on my retina, but that's not a car. And who's looking at that to see that? No, that doesn't work. And once you really confront that, okay, well, if it's not that, then what? You have to work in this field. It just grabs you. And that appears in all of my technical work, starting from an undergraduate at some level.
Sounds like you chose the right career.
I did.
Question number 6. Throughout your whole life, what has changed the most?
Oh, my goodness. In society, in science, could you?
I've left it purposely
be more
vague.
specific.
I've left it purposely vague so you can pick.
Oh,
it could be internal. It could be external.
Changed most? Well, that's very. I mean, I'm a great fan and follower of Steven Pinker, who's basically shown that everything's getting better. Violence has gone down, freedom has gone up, freedom of speech, all these kinds of things. And so, as change is I'm glad that those trends are continuing. And I'm sort of disappointed not enough people are as optimistic as I am about the future, including the hard problems like global warming and authoritarianism in the US and so forth. I'm just incredibly optimistic. So I'm not sure that answers your question.
I like it. Most change, things are getting better.
Things are getting better.
That's not bad. All right, question number 7. What do you find, and maybe you already answered this, I don't know. What do you find strangest about reality?
Well, I think it was Hermann Weyl who said, the unreasonable effectiveness of mathematics in describing the real world, that we can make sense of it, that, it's that we keep learning more, that it's making sense, that we're getting a coherent picture. Yes, they're hard problems, string theory, dark matter, there are things that we don't, cognition and, how I see red kinds of things. There are plenty of unsolved problems. Where did life come from? But this inexorable application of sort of scientific methods and towards increasing our knowledge, it's amazing that it works.
Mm-hmm. Yeah, I remember I taught a little bit of statistics myself, and I remember teaching about the normal distribution. And
Calcium, yes.
there is an equation, there's that bump, right? And there's an equation for that bump, and it's got like pi in it, and I forget all the details.
X squared over 2 sigma squared. Yeah.
There you go. And I'm teaching to these undergrads in psychology, and I can tell they're just not that impressed. But I'm like, come on, wouldn't that be crazy if you just discovered that there's a normal distribution of things statistically happen, and these numbers make an equation for it?
It's so many things like IQ.
Yeah.
Again and again. Yeah.
I get you. All right. A few more questions on this list. Number 8, when most recently do you remember feeling alive?
Sure. When I drank my orange juice this morning, or here now, looking out on this incredible vista, I feel, I feel alive all the time, except when I'm asleep.
Okay, great. Question number 9, what do you think your most unique trait is?
My thesis advisor said it. He said, David, your greatest asset is your greatest weakness. You have very broad intellectual interests, and you alluded to it, but I've had faculty positions in 10 different departments or programs. And so that's rare. And I'm a fellow of, I think, 7 different IEEE and Optical Society and SPIE and ISND, wide range. So it's sort of the breadth and not shallow. It's finding the problems that are deep, that require understanding from disparate fields. So if you want to talk about meaning in paintings, you got to know art history. You have to have studied art history, and I have this many books on art history at home. And I've spent tens of thousands of hours in museums, and as well as all the computer stuff. So it's not a little bit of this, a little bit of this. It's a lot of this that requires knowledge from around. And I know other people like this, but I would say that's one of my good aspects.
Good, yes, right. Can be double-sided, but yes.
Yes.
All right. Question number 10. If you weren't human, what would you be?
Oh, gosh. I'm a sailplane pilot and a glider pilot, and I love soaring. So some sort of hawk, I don't know.
Okay, a bird, yeah. We've seen some beautiful birds soaring around here as well. All right, great. That concludes our AI Wants to Know segment. A couple more to really pick your brain. So the next segment, number 3, is AI Leaders and Influence. This allows you to highlight some leading individuals, projects, organizations that might influence you. Could you tell us, like, maybe leaders in the world of AI, maybe who you'd love to see come on the podcast, for example?
Oh, Josh. There are so many. It's more the projects than the individuals. Now, there are names associated with them, but it's really, you have whole group. OpenAI and Google and Facebook, and all these groups have very strong, powerful, interesting, productive leaders and groups. I personally am most interested in images and image analysis. So, if you get Fei-Fei Li on from Stanford, she was one of the first who really collected these massive data sets that made these things available. But, I don't know. I won't go through all just the who's who.
It becomes political, I suppose.
And be careful. It can be a little bit political too.
All right, yeah, that's great though. And I think some people haven't realized how much has been going on behind the scenes at places like Google and Facebook and Amazon, I'm sure as well. I remember when I was studying, I was I don't know, surprised, but I thought it was interesting, like seeing some of the students I knew at Columbia who were studying, theoretical neuroscience or something, going on to work for DeepMind, I think it was. And then I think DeepMind got acquired by Google.
Yeah, absolutely. One of my prize students works there now.
Yeah. So it's been developing a long time. All right, segment number 4, AI resource list. So this is a chance for you to kind of share resources you might utilize in AI. I know you're very deep into sort of the technical stuff. It could be websites, applications, book, podcasts, learning tools. Any ideas come to mind, maybe?
Oh, I mean, there are some good online courses. There are some very good books. There's open software that you can use. Anything that I use, I think, would be too specific to my interest in art analysis for the average listener. So,
all right, well, tell us then. Let's go. Let's say if I'm interested in getting into what you're doing, what would be a book you'd recommend?
Well, my book, Pixels and Paintings,
Okay,
Foundations of Computer-Assisted Connoisseurship. I have, I don't know, 50 papers on computer analysis of art. My conference is called CVAA, Computer Vision and Analysis of Art. Look at the papers there. There are a couple groups around the world that are doing very interesting work. Ahmed Elgammal at Rutgers, Ingrid Daubechies down at Duke, and there are a few other, and Europe. There's some very good Bell in Germany. That's if you want to work on art, and more people should do it, I think.
Yeah. I mean, for myself, I think before meeting you, I wasn't, very aware of this whole field, and there's a lot of interesting things going on, and of course, like a lot of, research that's led by interest, right? Mm-hmm. Of course, it falls back into all these practical applications. Of course, I can imagine too. Mm-hmm. So,
well, maybe I should say how I got interested in using my, deep interests in pattern recognition, and then applied it to art. I mean, I come from a family steeped in the arts. I won't go through them all, but my great-grandfather was court painter to Crown Prince Rudolph in Austria, all the way down to my little sister, who was chief calligrapher in the White House under Bill Clinton, and lots of artists in between. But I was more interested in science and how do you put those together. And around the year 2000, very famous British-American artist David Hockney came up with a bold and very controversial theory that some Renaissance painters secretly projected images onto their canvas, traced them, and then filled in paint. And I was invited to do some technical analysis at a very large 2-day symposium at the New York Institute for the Humanities. And I came with an open mind. I thought, this is interesting. And then analysis after analysis, simulation, and so showed absolutely not, that it just, all the arguments just evaporated. And art scholars came up to me and said, this is really fascinating. I didn't know you could do this. And have you thought about this artist? Or what about this? Or I have this problem. And that's really how it expanded. So that theory is dead as a doornail, that Jan van Eyck secretly built a projector to do the Arnold Feeney portrait. It's not true. But it led to the development of all these techniques, especially in lighting analysis and perspective analysis and optical analysis and so forth. And that's what my book's all about.
Cool. All right. Last segment, number 5, AI tips. Any more like cool ways you use AI or you see people using, we might not have explored, things that people may not have realized are possible or available through AI, anything like that?
Well, I'll start with the negative. I prevent my students from using ChatGPT on their exams or any papers or anything like this.
Really?
Yes, I think. I know some professors say, you can use it, just let me know, but I'm still, no, I want people to express things in their own ways. So it's more prohibition than how to use it. I mean, we're using it all the time, and we call centers and, what gets mailed to you and what advertisements get served, all this is AI. And of course, in movies, it's everywhere. All those thousands of warriors who are battling on the field, that's all done with generative AI. So it's everywhere. I have no other special things to impart, I'm afraid.
Yeah, but I think that you raised an interesting tip. And actually, I know in a previous conversation, there's multiple sides to this that you could highlight. There is a value in, even if you can have someone or something else do something for you, learning how to do it, right?
Yeah, this is actually a very interesting thing because I teach a course at Stanford called Computational Symbolic Mathematics, and in it, it's using the computer to do the calculations that it allows us and during class to focus on how do you pose a problem versus how do you do the calculations to get the final answer. So like calculus, there are all these, integration by parts and partial fractions, substitutions, trigonometry, there are a whole host of techniques. More and more, we can just let a computer do that, like calculation. And the question is, how much do we benefit by spending all this time and learning to do a technique that the computer will do? And I go, I'm of two minds of this. Yes, if it were no cost, of course you should learn how to do this. But at the expense of other things, given that you have finite time, it's not so obvious anymore. And the kinds of problems that you can now address by using symbolic mathematics. I use Mathematica, which I think is a really superb software system, framework for computing. But the kinds of mathematical problems you can now solve, symbolic ones, not numeric, symbolic, is astounding. And if I had had this when I was an undergraduate, I'd probably be doing general relativity because I took general relativity, gravitation and cosmology and relativity in grad school. And I would do pages and pages of calculation. And on page 3, I missed a minus sign, or there was a factor of 2 somewhere. And, it would take hours and then try to find where that error is. Once you know that the answer should be this and you have some. But now you do it with symbolic mathematics and it allows you to focus on what does the equations mean? How do we interpret? Well, let me try different things. And so, for instance, when I'm teaching my course at Stanford on Fourier transforms, many of the mathematical steps will be done by computer. That, in other words, Fourier transform, bracket, this function, and then, now let's understand this. Let's look at the limits. Let's try, how does it depend on this parameter? So you don't have to do it all by hand. Mm-hmm. At least for those students, though, will have gone through calculation by hand, so it's not quite a fair comparison, but I think more and more mathematics is going to be done symbolically, on a computer. Mm-hmm. Just the way, like, dividing large numbers, you don't do that by hand anymore.
Right. And when we say symbolically, it's just to define it very clearly, it's, graphs and images that help explain mathematical
concepts. Not necessarily
concepts.
Graphs, but like, what's the integral of sine of x squared? You can't do this numerically, but you can do it symbolically. And there are algorithms that know how to do the transformations to get rid of these integral sign and get a final symbolic answer. Or differential equations, the second derivative of f with respect to x plus x times the first derivative, so find f of x. Well, you can't do that numerically, but you can do it symbolically. And when I first saw that, I know exactly where I was sitting in grad school when someone first showed me this, and it was magic to me, because you think of computers dealing with numbers, but this is dealing with the symbols. And this is a long time ago, decades ago, but it's just extraordinary development. I just love this stuff.
Okay. All right. So I'll summarize this, and you can correct me if wrong. But it's as AI evolves, be very intentional about what you want to leave to the computer and what you want to learn. And don't ignore either side of it. Don't ignore the fact that you could gain a much deeper insight of something by letting the computer assist you. But also, don't necessarily write your paper with ChatGPT, because you're going to miss out on developing your own skills.
Fair enough. Yeah,
there you go.
Close enough.
All right, perfect. The sort of final question here is, where can the listeners and viewers here learn more about you and the projects you're working on?
Oh, if you just do a Google search, I have a Wikipedia page which is not very up to date, or go to Google Scholar and just download my papers, or academia.edu or any of those places. For me personally, or my conference, CVAA, Computer Vision Analysis of Art. But wait for my book, out in September.
Perfect. All right. Well, it's time for another safe landing here at the outer edges of the AI universe for today. Thanks. This is your Captain Eathan Janney. On behalf of our guests and the entire crew, I'd like to thank you for choosing to voyage with us today. We wish you a safe and enjoyable continuation of your journey. When you come back aboard, make sure to bring a friend. Our starship is always ready for more adventures. Head to Spotify or iTunes right now. Rate us, share your thoughts. Your support and feedback mean the world to us. Don't forget to visit edgeofai.xyz to learn more. Connect with us on all major social platforms by typing edge_AI. Enjoying the exciting conversations happening online. And before we sign off, mark your calendars for our next voyage, where we'll continue to unravel the mysteries and advancements in AI. Until then, we'll see you next time.
The views and opinions expressed on Edge of AI reflect solely those views and opinions of the show hosts and its guests. Please make sure to do your own research. While we make every effort to ensure that the information about AI technology is accurate and up to date, we cannot guarantee its accuracy, completeness, or timeliness. We make no representations or warranties of any kind with respect to the information, products, or services discussed. Please be aware AI may occasionally generate incorrect or misleading information and produce offensive or biased content. Under no circumstances shall we be liable for any loss or damage, including, without limitation, indirect or consequential loss or damage, or any loss or damage arising from loss of data or profits arising out of or in connection with the use of technology discussed on our podcast. Additionally, our show is not financial advice. You understand that you are using any and all information available on or through this podcast at your own risk. Whenever making financial decisions, we recommend doing your own research and talking to your accountant for financial advice. Lastly, time to time, we may feature sponsored content on the show for which we receive value, and we may share links for which we receive a commission if you make a purchase through one of these links. Refer to our website, edgeofai.xyz, for our full disclaimer, terms and conditions, privacy policy, and copyright notice.